This is sodium hydroxide, so it's sodium hydroxide, and this is a ionic because of the sodium, which is a metal. So since this over here is a polyatomic ion, we wouldn't draw the Lewis dot structure, right? And then one way that you could mess this up is putting sodium and then hydrogen, because you're leaving out the oxygen, which makes this the polyatomic ion hydroxide.
So this is silver iodide, which is ionic because silver is a transition metal, but silver always has a charge of +1, and iodide has a charge of -1. So the formula for this would be Ag and then I. And to draw the Lewis dot structure, we would have Ag, I, and iodine has 7 valence electrons. And silver has 1. So silver will give its 1 to iodine. And we draw the brackets, and it's -1, +1. One way you could draw the Lewis dot structure wrong for silver iodide is if you took iodine's valence electrons and put it on silver. So silver has 1 valence electron, and if you went and put 7 valence electrons over on silver and taking them from iodine, that would be the wrong Lewis dot structure.
So this compound is carbon dioxide. So it's carbon dioxide, and it's a covalent bond because carbon is a nonmetal and so is oxygen. And to do the Lewis dot structure, you would have carbon in the middle and a double bond on each side with oxygen, and then both of the oxygen bonds would have 2 lone pairs on each side, and that would be the Lewis dot structure for carbon dioxide. Somebody could draw the Lewis dot structure wrong by only putting 1 bond on between the oxygens and the carbon, and that would be the wrong amount of valence electrons between the two. And nitrogen is a nonmetal, so this compound is a covalent bond, and the compound would be written out as NF3 because it says you have trifluoride, which tri stands for 3. And then to draw the structure, you would have an N, F, F again, and then F, and then you would have 1 lone pair there, and then 3 on every side of fluorine, which would be like that, and it would be trigonal pyramidal. Because it has 3 sets of lone pairs on each side of fluorine. So one way you could do this wrong is you could not put a lone pair on nitrogen, and you could add a double bond on fluorine, which would be wrong because then you'd have the wrong amount of valence electrons.
Linear because it has no lone pairs, it's in a straight line, and it's 180 degrees. And then this one is trigonal pyramidal because it has lone pairs, and it's 109.5 degrees.
So this is cesium oxide. So cesium oxide, which is ionic because cesium is a metal, and we have 2 cesiums because cesium is a charge of +1 and oxygen is a charge of -2. So when you draw the Lewis dot structure, you have 2 cesiums and 1 oxygen. And oxygen has 6 valence electrons. 2, 4, 6. And cesium has 1 valence. Each cesium has 1 valence electron to give away. So there's 1, and then there's 2. So you have here, which this is a charge of -2, and this is a charge of +1. is if you look at the charges, and because of the charges, draw 1 cesium and 2 oxygens. So oxygens have 6 valence electrons, so 2, 6. And if you did that, you would only have 1 valence electron to give away. But if you still messed it up and you put 4 valence electrons, when you look at the charges after, you would notice that oxygen has a charge of -2, and this oxygen has a charge of -2, while cesium only has a charge of +1, and this would equal -3, which is not right. It should equal 0.
Okay, this is vanadium phosphite. It's vanadium 5 because phosphite has a subscript of 5, which shows that vanadium has a has a charge of 5, and phosphate has a charge of -3. So that's that. And it's ionic because vanadium is obviously a metal, so that makes it ionic, because ionic is when it's metal and non-metal. Okay. And one way a person can do this wrong is because if they don't switch the subscripts to know the charge of the elements and the polyatomic, so that would be wrong because they would think that vanadium has a charge of 3 and phosphite has a charge of 5, and that's not right.